හරලා අපි එහෙනම් ක්ලාස් එක පටන් ගමු නේ. Let's start the base chemistry, right? So I wish you got this tube, right? This one. හරි මේ tube එක ඔයාලා නැති කියලා මම හිතනවා. Right, let's start lesson, right? From the first day, right? Right. දැක්කේ නෝ. Question නේ. shape මේ ළමයි ඔයගොල්ලෝ මාව ඇහෙනවද? මේ ඔයගොල්ලෝ මොනවා හරි ප්‍රශ්න තියෙනවා ළමයි කෙලිම මේ මයික් එක ඔන් කරලා අහන්න පුළුවන්. හරිද? right මයික් එක ඔන් කරලා ඔයගොල්ලෝ questions අහන්න පුළුවන් ඕන එකක්. ඊට පස්සේ මයික් එක ඔෆ් කරා. right ඔන් කරලා question එක අහලා ඊට පස්සේ මයික් එක ඔෆ් කරන්න නැත්නම් ඒක දිගටම අර වාට ভাইබ්‍රේට් වෙයි. හරි okay, let's start the session. Right, at the first page we are introducing you the three theories which will define the acids and bases. Right, there are three theories which will define the acids and bases. We use three theories, right, to define the acids and bases. Right, let's discuss those things one by one. Right, okay, theories on right acids and bases. We have three theories, right? Number one is the Arrhenius theory. Arrhenius theory, right? Arrhenius theory is the compounds which release H pluses to the aqueous medium. The compounds which release H plus ions to the aqueous solution are called as acids, while the compounds which release OH minus ions to the aqueous solution, to the aqueous medium, are referred to as bases. That is how the Arrhenius theory introduced us the acids and bases. Right? Okay, a simple theory. That is the theory we had used, right? Actually, when introducing acids and bases in your O-levels. In O-levels, the acids and bases are introduced with the use of Arrhenius theory. Right? So it says, simply it says, species which release H plus ions to aqueous medium are known as acids, while the species which release OH minus ions to aqueous mediums are known as bases. Right? Simply acids and bases can be categorized using this theory. So that we can say the HCl is kind of acid. HCl in aqueous solutions release H plus ions to the medium. So HCl, as it releases kind of H pluses to the aqueous medium, can be referred to as acids. Right? In general, we can say, in general, if HA is a compound and if it release, if it dissociate, ionize like this, then HA can be referred to as an acid. HA can be referred to as an acid, right? This is general form, right? Oh, it can be released like it can be written like this as well, right? It can be written as this as well. So if you take the HA and when reacting with water in the aqueous solution, as this one releases H pluses, right, it will come ultimately come up as A minus, and that released H plus can be grabbed by the H2O to form the H3O plus. The same thing can be written in this form as well, so that this HA can be referred to as an acid. So here H plus is released to the aqueous solution in simple form, or one can say that H plus released to the aqueous medium can be grabbed by water molecules in the medium and can form H3O plus as well. So still this HA is considered as an acid, right? Species which release H pluses to the aqueous solution are referred to as acids. Clear? Right? Like that, right? We can write equations for bases as well, right? Bases are the ones which release OH minus ions to aqueous solutions, right? Simply as that, right? So these things are appearing in your note, right? So no need of writing this stuff, right? So if you are thinking of bases, right? Some good example is the NaOH. It's a base, you know, from your small ages. So NaOH is considered as a base as it releases OH minus ions to aqueous solutions. See, so that NaOH can be referred to as a base, right? Now, in generally, we can write the equation like this: if MOH is kind of a base, it will release some OH minus ions like this to the aqueous solution. See, OH minus ions are released. Or one can write it like this: with water as a reactant, right? As OH minus ions are released, this will come up as M plus. As the OH minus released, this will come up as M plus, and this OH minus connects with H2O. OH minus with H2O. OH minus with H2O. Right? OH minus with H2O can be written as H2O with OH minus. That is going to be H3O2 minus. Right? Like in earlier case, H plus and H2O can be written as H3O plus. Like that, OH minus plus H2O can be written as 3 H atoms, H3O2 minus. Right? That form also can be applied. Right? So make that change there. එතන ළමයි තියෙන පොඩ නේද? අර highlight කරපු පොඩ වැරදිලා තියෙන්නේ. Example, it should be not the H2O2 minus, it should be H3O2 minus. H3O2 minus. This should be 3, right? H3O2 minus. At that box, the gray colored box, right? The hydroxyl ion also exists in the hydrated form in the aqueous solution. This is referred to as the hydrated form of the hydroxyl ion. This is referred to as the hydrated form of hydroxyl ion. Right now, Okay, this is the simplest theory which introduces us the acids and bases. The ones which will release H pluses are the acids, and the ones which will release OH minus ions are the bases. All happens in aqueous solutions. Right? Okay. So we have some failures with this one, right? Even though this is the first theory introduced, right, to define acids and bases, nowadays we are not that much following this theory, right? Because some failures are there. So not all acids, right, can be categorized with the use of this theory, or not all the bases can be defined with the use of this theory. That is why nowadays we are not following this theory that much, even though this has been used to introduce use acids and bases in your O levels. This is not that much followed beyond that, right? So let's think of such situations. If you are to think of NH3, NH3 is referred to as a base. NH3 is referred to as a base. All right, but you see, you won't see any kind of OH minus section, any kind of OH minus part appearing with the NH3. So if you are to come up with the NaOH, it consists of some OH section, OH minus section to release as OH minus ions. But when it comes to NH3, you don't see such kind of part, such kind of segment as OH minus inside the NH3. So you can't clearly say that NH3 releases OH minus ions to the aqueous solutions, right? Okay, so to account the basic nature of NH3, right, this theory can't be used, right? So some acids are also there which are not with H pluses, right, in their chemical formula. Right, when considering their chemical formulas, we won't see the appearance of hydrogens in some of the acids, right? Then those also can't be, right, defined. The acids can't be defined with the use of this theory. As an example, I can introduce you some acid like AlCl3. You know, the AlCl3 in aqueous solutions behave as acids, right? So the pH is less than 7 when you have AlCl3 in your aqueous solution, right? So like that, for some acids as well, as they won't contain any hydrogen parts there in their chemical formulas, you can't comment on the acidic nature of those with the use of this theory, right? So this theory fails. Then the scientist said, look for another new theory which can account the acidic nature and the basic nature of all the acids and bases. There, they found a good theory which is nowadays known as the Lewis theory, Lewis acid-base theory, right? Yes, Lewis is the scientist who came up with that theory, right? The same Lewis we had discussed with the Lewis structures, right? The Lewis structures la ගැන කතා කරපු Lewisම තමයි, right? So he came up with a good theory, another good theory to account for acids and bases. Actually, we know that theory, the Lewis theory, the Lewis acids and Lewis bases, right? We know about that, right? So what are the Lewis acids and what are the Lewis bases according to Lewis theory? So we had learned that theory actually in our unit 2 when we are discussing about the dative bond. We had learned about that thing, Lewis acids and Lewis bases. NH3 can be referred to as a Lewis acid, and like BCl3, NH3 can be referred to as a Lewis base. Lewis base. while AlCl3, those things can be referred to as Lewis acids. Actually, AlCl3, FeCl3, those are Lewis acid catalysts now, which are used in organic chemistry as well. Right? So let's discuss about that theory. What is the definition there? The Lewis acid base theory. Right? Right. Okay. So we were discussing about the Lewis theory. Right? Number 2, Lewis acid base theory. But it says the species which can donate lone pairs are known as Lewis bases, while species which can accept lone pairs for that they should have some empty orbitals. Right? Species with empty orbitals to accept lone pairs are known as Lewis acids. Right? So if you think of this reaction, we have the NH3 react with BF3. When NH3 reacts with BF3, this is the same example we had discussed when we are discussing about the dative bond. There, NH3 will donate this lone pair, its lone pair, to the empty orbital of BF3, like this, to produce the right this compound. Right, the BF3 dot NH3. Right, in this reaction, the species which donate the lone pair, the NH3, is known as the base, the Lewis base, and the species which had accepted that lone pair is known as the Lewis acid. Right, this is the Lewis theory. Totally concentrating on lone pairs. Totally concentrating on lone pairs. The lone pair donors are referred to as Lewis bases, while the lone pair acceptors are referred to as Lewis acids. Totally concentrating on lone pairs. Not like in the Arrhenius theory. In Arrhenius theory, to define acids, they have used H pluses, the H plus donors, H plus releasing species are acids. And to define bases, they have used OH minuses. Species which release OH minus are the bases. But in Lewis acid base theory, the theory is totally concentrating on lone pairs. The lone pair donors are the Lewis bases, while the lone pair acceptors are Lewis acids. Actually, this theory can be used to discuss about the acidic and basic natures with species not with H pluses as well as OH minuses in their chemical formula. Even you don't have H plus in your chemical formula, the BF3 can act as an acid. Even though you don't have OH minus part in your NH3, still NH3 can act as an base. The reasonings, right, can be discussed with this theory. Lone pair acceptors are the Lewis acids and lone pair donors are the Lewis bases. Clear? Right? Totally concentrating on lone pairs. Right now? Right now? So you can go to the note, right? So you can highlight the stuff there. Acids are substances which accept electronic lone pairs. Just highlight that phrase. And next phrase, bases are substances which donate lone pairs. Right? Acids are substances which accept electron lone pairs, and bases are substances which donate electron lone pairs. Right? Lone electron pairs. Right? Okay. So just highlight. And with the use of this theory, we can account for acidic and basic natures of more substances, right, than the Arrhenius theory, right? Okay, you see, with this one, we are able to comment on the basic nature of even the water, right? The basic nature of NH2, the OH minus, the right NH2, right, NH2 minus, right. So basic nature can be commented with the use of this theory, as well as the acidic nature of Lewis acids like AlCl3, like BF3, BeCl2, which coming up with empty orbitals to accept lone pairs, right? Anhydrous zinc chloride is also a kind of a Lewis acid, which is used in organic chemistry, which is also used as a catalyst. FeCl3, right? Those are Lewis acids. So the acidity can be commented with the use of this theory, right? Okay, these two theories are actually known, right? We know about these two theories before today, right? This thing is actually discussed with the unit 2, right? But when it comes to acid-base chemistry, this lesson, the acid-base equilibrium, we are not actually using both of these theories. We are coming up with another theory called as the Bronsted-Lowry theory. Bronsted-Lowry theory. That is the major theory we are using throughout this lesson. Let's learn about the Bronsted-Lowry theory, which is the third theory we are introducing today, right, about the acids and bases, right? Let's copy that thing. So actually, this acid-base chemistry lesson totally with this theory, right? We use the Bronsted-Lowry theory in this whole lesson, right? Not the other two stuff actually. Right, let's discuss about what this means, how the acids and bases are defined with the use of Bronsted-Lowry theory. Right? Number 3, theory number 3. Bronsted-Lowry. Right? Sorry, Lowry. Bronsted-Lowry theory. Right? It is like this, Lamai. In Lewis theory, they were totally concentrating on the lone pairs. When it comes to Bronsted-Lowry theory, they are totally concentrating on the H pluses. They are totally concentrating on the H plus ions, or one can say protons. H plus ions means the protons. The Bronsted-Lowry theory is actually totally based on the protons, proton donors and proton acceptors. Species which will release protons or which are capable of releasing protons or H pluses are referred to as acids, Brunstad-Lowry acids, while the species which are capable of accepting those H pluses, accepting those protons, are known as Brunstad-Lowry bases. Right? Species which release H pluses are known as Brunstad-Lowry acids, while the species which accept H pluses are known as Brunstad-Lowry bases. The theory totally concentrating on H pluses, the protons. Right? Species which release H plus ions are known as Brunstad-Lowry acids, while species which accept H plus ions in a reaction are known as Brunstad-Lowry bases. Right? So let's discuss some examples here. As examples, see, if you think of this HCl, right? In aqueous solutions, what will happen? HCl will ionize to release H pluses, and that H plus will be grabbed by H2O, guys, ultimately to form the Cl minus ions and H3O plus. So if you are referring to this equation, this chemical equation, this acid-base reaction, you clearly see some H plus from here, is actually released towards here, right? H plus actually released from here to here. Right? H plus is released from HCl to H2O. So we can comment, according to Brunstad-Lowry theory, the H plus releasing species, as your acid, and the H plus accepting species as your base. To produce the Cl minus, HCl has released some H plus. To come up as H3O plus, the H2O should accept that H plus. So H plus releasing species is referred to as the acid, and the H plus accepting species is referred to as the base, according to Brunstad-Lowry theory. Right? Okay. Let's come up with another example. The hydrolysis reaction of NH3. Now the hydrolysis means reacting with water, right? Hydrolysis reactions means the reactions involving water, reacting with water. Earlier it was the hydrolysis reaction of HCl. Now we are considering the hydrolysis reaction of NH3. NH3 is referred to as a weak base. So that's a double arrow situation. So what will happen? NH3 is considered as kind of a weak base because it will increase it is referred to as a base because it will increase the OH minus ion concentration in your water, right? So how come? Due to this reaction. So what happens is, actually one of the H plus, one of the hydrogens from water will be released as H plus ion, right, towards here. So this is just the movement of the H plus ions, right, not the movement of electrons. like in organic chemistry. This is the movement of H plus ions, right? So one of the H plus from here will come to here to produce the NH4 plus ion and the OH minus ion. So if you want to examine this reaction, that's this acid-base reaction, you clearly see some H plus is released from H2O to produce the OH minus. So that the H2O is referred to as the base in this acid-base reaction. Sorry, H2O is referred to as the acid of your acid-base reaction, the species which release the H pluses, and that H plus has been absorbed or grabbed or accepted by the NH3 to come up as NH4 plus, right? So that the H plus acceptor is referred to as the base according to the Bohr-Lowry theory. So this is how, right, we are designing acids and bases in acid-base reactions, right? With the knowledge of H plus movement. The H plus releasing substances, H plus donors are referred to as acids, while the H plus acceptors, the H plus gaining substances are referred to as bases. Right? The thing is clear now? If you need another example, right? If you need another example, I can give you another one in the form of the hydrolysis of CH3COH. See, you can write this one as well. If you think of the hydrolysis of CH3COH, acetic acid, hydrolysis, right? Reacting with water. It is also a double reaction. There what happens? This guy will release this H plus towards water. Right? To produce the acetate ion, CH3COO minus ion, and this H3O plus. So this thing is referred to as your acid here. The H plus releasing substance is the Bohr-Lowry acid, and H plus accepting substance is the Bohr-Lowry base. Clear no? Okay. So we just discussed about the forward reaction, the acid and base involved in the forward reaction in these two cases. What about the reverse reaction, Lamai? What about the reverse reaction here? What about the reverse reaction here? So when we are thinking of the forward reaction of this hydrolysis of ammonia to produce the NH4 plus and the OH minus from the forward reaction, the H2O should release some H plus and NH3 should accept that H plus. That is why, according to the forward reaction, H2O is referred to as the acid and the NH3 is referred to as the base. What about the reverse reaction? What about the reverse reaction, Lamai? Reverse reaction. If you think of this reverse reaction of producing the NH3 and H2O, starting from the NH4 plus and the OH minus, the reverse reaction produce the NH3 and H2O. The reverse reaction. There we can also see to produce the NH3 from NH4 plus, you have to release one of the H pluses towards the OH minus here. When thinking of the reverse reaction, you have to release some H plus from NH4 plus towards OH minus. Then only you are capable of producing the NH3 and the H2O. By releasing H plus from NH4 plus, it will convert to the NH3, and by accepting that H plus, right, by the OH minus, right, it will convert to the H2O. So when considering reverse reaction, this kind of a H plus transfer occurred, so that when considering reverse reaction, the reactants of the reverse reaction, the NH4 plus is referred to as your acid, the H plus releaser, and OH minus is referred to as your base. Right now? This is about the reverse reaction. You can comment on the reverse reaction of this thing as well. To produce these two guys, by the reverse reaction of CH2CO minus and H3O plus, you clearly see some H plus should be released from here to here. Yeah, from here to here, sorry. Right? That is how these two products are produced by the reverse reaction, right? So we can say the H plus releaser, the H2O plus is your acid, and H plus acceptor, the CH2CO minus is your base here, when considering reverse reaction, right? So acids and bases can be classified with the use of Brown's-Lowry theory. And that can be applied for even for the reverse reaction as well. Okay, right. Just go to the next page, Lama. Just go to the next page and see. These two things are written there, right? These two things are written there. The NH3 is hydrolysis reaction, and the right hydrolysis reaction of acetic acid is written there, right? Okay. See, right? I'll add this thing again, right? Here, this reaction. Right, NH3 is hydrolysis reaction. When writing these reactions in acid-base chemistry lesson, you are always supposed to come up with the physical states, right? Physical states are must. This physical chemist, right? So this is the guy which has accepted the H plus from here to do the forward reaction. So this is the acid which releases H plus, and this is the one which accepted, right? Is the base. When it comes to reverse reaction, this guy releases the H plus towards here to form the NH3 and H2O, right? So this is the acid, this is the base, right? So Lamai, when considering these double arrow situations, double arrow reactions, right? So forward reaction is with the acid and base, as well as the reverse reaction. The reverse reaction is also with the acid and base. Then we can pair these guys. We can pair these guys like this, right? We can pair the base of the forward reaction with the acid of the reverse reaction like this. These are pairs. Acid of the forward reaction and the base of the reverse reaction. These are pairs. These are pairs only with a difference of just one H plus. The difference between the pair is only a 1 H plus ion. 1 H plus ion. The difference between this pair is only a 1 H plus ion. It's a pair, acid and base pair, with a difference of just 1 H plus ion between them. These two are can be considered as kind of an acid-base pair with a difference of just 1 H plus between them. And those are considered as conjugate pairs, conjugate acid-base pairs, right? Conjugate acid-base pairs, or one can say conjugate pairs, right? Okay. So if you are with a acid-base pair with just only a 1 H plus difference between them, such a pair can be referred to as a conjugate acid-base pair. Conjugate acid-base pair, right? Okay. Conjugate acid-base pair or a conjugate pair. So these two can be labeled as a conjugate pair. Just terminology, right? Just terminology. These two guys can be referred to as a conjugate pair. If between any pair, if only a H plus difference appears, if between a pair, if only a H plus, a difference of only a H plus appears, then we can name them as a conjugate pair. We can refer them as a conjugate pair. So Mahinda and Mahinda H plus, Mahinda and Mahinda H plus can be referred to as a conjugate pair. Anura and Anura H plus is a conjugate pair. Mahinda and Mahinda H minus, Mahinda without a H plus, right? That means Mahinda H minus, one can say, right? It's a conjugate pair like that. HCl and Cl minus, just the difference of H plus appears between them, a conjugate pair. CH3COH and the CH3CO minus, see, CH3COH and the CH3CO minus, right? CH3COH and the CH3CO minus, just the H plus difference appearing between the pair, right? Between this pair, just the H plus difference appears. So that is, so that pair can be referred to as a conjugate pair. If only a H plus difference appear between the pair of species, such pair can be referred to as a conjugate pair, even these two. Conjugate pair. Right? Okay. Clear? No? Conjugate pair. So just draw these two stuff there at the space provided there. Just draw these two stuff at the next page, page number 2. Some space is there. Right. I'll go to the definition after you have written this thing. Right. Just write these two stuff. This is the hydrolysis of NH3. This is the hydrolysis of acetic acid. And label this pairs, right? Conjugate pairs. अरे අපි හිමින් කරන් යනවා හරි කලබලයක් නැහැ හරි හිමින් කරන් යමු හරි conjugate pair කියන concept එක පැහැදිලිනේ හරි if only a difference of H plus ion appear between the two chemicals, then such a pair of chemicals can be referred to as a conjugate pair. That is the definition. No? If only a if only a difference of only a H plus ion appear between two chemicals, two species, right? Such a pair of chemicals or species can be referred to as a conjugate pair. That is clear? No? Right. Okay. So let's go to the definition there of the conjugate base and a conjugate acid. It's like this, Lamai. So if they have asked you to write the conjugate base, if they have asked you to write the conjugate base of a given acid, if they have asked you to write the conjugate base of a given acid, what you need to do is just remove an H plus, just remove an H plus, just remove an H plus and write the remaining. And write the remaining. See what it says? Right, it's like this. Right? If they have asked you to write the conjugate base of an acid, let's say conjugate base of, let's say, CH3COH. If they have asked you to write the conjugate base of an acid, what you have to do is just remove one of the H plus, just remove one of the H plus from your acid and write the stuff. That is your conjugate base. That is going to be, just remove one of the H plus from here. It is going to be then CH3COO minus. Just remove one of the H plus from here and write the remaining. That is how you are supposed to come up with the conjugate base of an acid. Right? If they have asked you to come up with the conjugate acid, of a base, of a base, conjugate acid of a base, let's see, of NH3, then what you are supposed to do is just add an H plus, just add an H plus and write the stuff. Add an H plus to this one, add H plus to this one. So that is going to be NH4 plus, NH4 plus, right? That is how we are supposed to come up with the conjugate acid if the base is provided. So anyway, only a H plus, a difference of only a just one H plus should be there between the two species. A difference of just the one H plus should be there between the two species. Yes, you know, just the one H plus difference. Right? Okay? Clear? So it's like this now, man. If they have asked you to write a conjugate species to a given species, if they have asked you to write a conjugate species to a given species, what you need to do is you have to just add a H plus, or you have to just remove a H plus. So only H plus difference would appear, no, between the two species, right? You have to remove an H plus or add an H plus if they have asked you to come up with the conjugate species of a given species. So whether it is to remove an H plus or add an H plus will be decided by whether they are asking about the conjugate base or about the conjugate acid. If they are asking about the conjugate base, base are the substances with lack of H pluses. Base are the substances with lack of H pluses. That is why bases are keen to accept H pluses. Get this logic. According to the Brusel-Lowry theory. According to Brusel-Lowry theory, bases accept H pluses. Why is that? Because those are the ones which lack of H pluses. As those are lack of H pluses, those are keen to accept H pluses, gain H pluses. Right? If they have asked you to come up with the conjugate base, then what you need to do is just remove an H plus, if they have asked you to come up with the base, because bases are the ones which are lack of H pluses. Just remove an H plus and write this stuff. Lack of H plus. If they have asked you to come up with the acid of a given species, then add some H plus, add one H plus, add an H plus and write the species. Right? Acids are the ones with more H pluses. That is why they are keen to release H pluses. If you are with enough H pluses, or if you are with more H pluses, you are more keen to release them. If you are with some excess, you are keen to release them. That is why acids release H pluses. That is what acids do, no? The ones which release H pluses, no? So that if they have asked you to come up with the conjugate acid of a given species, what you need to do is just come up with one H plus more. Just add an H plus and write the stuff. Because among the pair, the one which is supposed to write is the one with more H pluses, as they have supposing you to come up with acid. Conjugate acid එක ලියන්න කියලා වාට කිව්වොත් question එක කිව්වොත් conjugate acid එක ලියන්න කියලා, what you need to do is you have to add an H plus to the given species and write as the conjugate acid. Right? Conjugate pair එක acid එක ලියන්න කියලා කියන්නේ acid එක කියලා කියන්නේ වැඩියෙන් H plus තියෙන කෙනා. Acid means the one with more H pluses. So conjugate pair එක acid එකක් ලියන්න කියලා කිව්වොත් you have to come up with a species with more H pluses. So you have to add some H plus to come up with the acid of a given species. To come up with the base of a species, conjugate base of a species, what you need to do is just remove one H plus. The base එකක් කියලා කියන්නේ H plus අඩුවෙන් තියෙන කට්ටියට. ඒකනේ bases tends to accept H pluses. Right? So if they have asked you to come up with the base of a given species, conjugate base of a given species, what we do is just remove an H plus and give the species. Right? Na? Logic is true. Okay. Right. So with the use of that thing, just try to come up with some answers at the questions appearing in the page number 2. Page number 2, the bottom part, the test of knowledge questions. They are saying identify the conjugate base or acids of the following species. Just try to come up with good answers for them. Right? One is an answers to ලියන්න බලන්න. Right? The question is like this: identify the conjugate acid and base over the base of following species. Right? Few things are given. Conjugate acid of H2O. I write it this. Conjugate acid of H2O. Then conjugate base of H2O. These are things they are asking, right? Conjugate acid of NH3. Conjugate base of NH3. Next one. Conjugate acid of CH3OH. Conjugate base of CH3OH. Let's try to come up with the answers for me. Next stuff. Conjugate acid of HCO3 minus and conjugate base of HCO3 minus. Number 5. Conjugate base of HF. Conjugate base of H2SO4. H2CO3. Acid of CO32 minus. Conjugate acid of NH2 minus and conjugate acid of CH3COO minus. Let's try to come up with answers for these things. Conjugate species. Right, that's right. Conjugate acid of H2O. So we are supposed to write the acid. So we are supposed to write the species with more H pluses. Acids means more H pluses. So just add an H plus to this one and write. That is the H3O plus. Add an H plus. Conjugate base of H2O. So we are supposed to come up with the base. That means the species with less H pluses, less H pluses. So just remove an H plus from this thing and write. That is OH minus. Removing hydrogen will give you OH, H plus no, so OH minus. The difference between two should be just an H plus. Difference between two should be just an H plus. Yes. Now conjugate acid of the NH3. Now we are supposed to write the acid. Acid means we are supposed to write the species with more H pluses. Acids. Species more H plus. That is why they released it. Right? So just add an H plus. Add the H plus to this one and write NH3 with H plus. That is going to be NH4 plus. Conjugate base of NH3. Base means we are supposed to write the species which is with less H pluses. So just remove an H plus from this one and write. The NH3 removing H plus will give you NH2 minus. Removing H will give you NH2. We are removing H plus, right? So NH2 minus. The difference between two should be just an H plus. This one. Conjugate acid of CH3OH. To come up with the acid, we are supposed to add an H plus. Acids are the ones with more H pluses, right? So we have to add some H plus here to this one. So CH3OH with some H plus, it will be the CH3OH2 plus. OH2 plus. OH with H plus, OH2 plus. Conjugate base of CH3OH. Conjugate base of CH3OH. Base means you are supposed to come up with the one with less H pluses. So one with one H plus less. That means you are supposed to release some H plus from this one, right? So CH3OH releasing H plus means it will give you CH3O minus. O minus. As this H plus is released, just the O minus. Right? Alkoxide ion, alkoxide ion. This one. Acid, we need to come up with acid. Acid means you should write the species with more H pluses. Acid means the species with more H plus. So that means you have to add some H plus to this one and come up with the species. HCO3 minus with H plus, it will give you H2CO3. HCO3 minus with H plus, H2CO3. Right? This one. Conjugate base of HCO3 minus. Conjugate base of HCO3 minus. So we are supposed to copy the base. Base means the species with less H pluses. So that you need to release one H plus from here, as we are considering conjugate pairs, right? Just one H plus difference would be there, right? So release an H plus from this one and write. So releasing H plus from this thing will give you CO3 2 minus. Releasing hydrogen will give you CO3 H plus no. So releasing a plus from here will give you 2 minus then. So if you add some H plus, definitely you should compute this one. If you add some H plus, you should compute this one. Right? This is the ratio, the conjugate pair. What about this? Right? See, conjugate base of HF. We are supposed to copy the base. Base means the species with less H pluses. So that means you need to release some H plus from this way. Remove some H plus from this way. So that will give you F minus. Conjugate base of H2SO4. So you copy with the species with less H pluses. Base. This is less H pluses, right? So release some H plus from here and write. So that is going to be HSO4 minus. One H plus is released. When you release one H, that is HSO4. H plus is released, so minus. So base of this thing, that means release some H plus and write the stuff, right? So that means HCO3 minus. Right now? Okay. These things. Conjugate acid of this thing. Acid means the species with more H pluses. So you have to add some H plus. Add some H plus. So it is going to be HCO3 minus. H plus is added to this thing. H plus is added to this thing. H plus with this one. So HCO3 plus thing is added. So 2 minus plus 1 is minus 1. This thing. Conjugate acid of NH2 minus. So acid, we are looking for acid, so we are looking for species with more H pluses, right? So H plus should be added here to this one, right? So that is NH3. For this one, conjugate acid, so we need to add some H plus because we are looking for the acid. So some H plus should be added to this one. CH3COO minus, and with that H plus is going to be CH3COOH. Anyway, between these pairs, only H plus, a difference of just one H plus should appear. Right now, this is how we are supposed to write the conjugate pairs if a species is given. Right now, okay, just complete this stuff. So if you have any questions, you can ask, right? Right now, okay, let's move to the next session. Right. Okay, let's move to the page number 3. So there we are going to discuss about some more important stuff about this conjugate pairs, right? Right. This is clear now? Right. Okay, see what it says. Right, some important facts on conjugate acid base pairs, right? This is the same. Right. Some important facts. Right. On conjugate acid base pairs. Right. This is us. So we have to discuss about 3 facts there, right? So for the first thing there, right? See what it says. The first fact at the page number 3. In this set, let's go to that and then I'll explain the stuff, right? If an acid is strong, its conjugate base has no measurable strength. If an acid is strong, its conjugate base has no measurable strength. Just highlight this stuff, Lama. Just highlight that statement. Just highlight that statement. Then I'll explain. It said, if an acid is strong, its conjugate base has no measurable strength. See what it says. See what it says. So we know that HCl, if you need an example, we can say like this. We know that HCl is a strong acid. HCl is a strong acid. Right? HCl is a strong acid. You know that, right? HCl is a strong acid. So what this statement says? It says if your acid is strong, its conjugate base is not with a measurable strength. is not with a measurable basic strength. So what is the conjugate base of HCl? What is the conjugate base of HCl? So to come up with the conjugate base, right, what we need to do is you have to just remove one H plus and write the species. So if you remove one H plus from the HCl, we will come up with Cl minus. So Cl minus is the conjugate base of HCl. So this statement says that Cl minus is not with any measurable basic strength. If your acid is strong, as HCl is strong, its conjugate base, the Cl minus, is not with a measurable strength. That means not with a measurable basic strength. For a base, the strength means the basic strength, right? Okay. Let's come up with that idea clearly. Let's try not to by heart this stuff. By heart karana tu අපි මේක තේරුම් ගමු. It's like this now. So we know HCl being a strong acid, it will completely dissociate. It will completely, fully dissociate to H plus and Cl minus. HCl being a strong acid, it will completely dissociate to H plus and Cl minus. So this is your conjugate base. This is your conjugate base. This is your conjugate base. So with this reaction itself, it is very clear that Cl minus will never accept an H plus to produce the HCl again. With this reaction, with this straight arrow reaction, as it's a strong acid, we have to write a straight arrow reaction. With this thing, it is very clear that Cl minus is not going to accept an H plus to come up with the HCl. Why? Because the reverse reaction won't appear. Reverse reaction is not there with the HCl. Just a straight arrow reaction. Because it's a strong acid. Strong acid means completely dissociate, completely ionized. That means only a single arrow, straight arrow reaction will represent the equation. That means Cl minus is not attracting H pluses. Cl minus is not attracting H pluses. Cl minus is not accepting H pluses to produce the HCl. That means Cl minus is not accepting the H pluses, means Cl minus is not with any basic property. Bases are the ones which accept H pluses according to Bronsted-Lowry theory. So Cl minus is not going to accept H plus to produce the HCl again. So that Cl minus is with no basic property, no measurable strength, no measurable basic strength. That is why this reverse reaction won't appear with this one. If Cl minus is keen to accept an H plus, if Cl minus is with some basic property, so that it will accept an H plus, so that this reverse thing should appear then. As Cl minus is not accepting any H pluses, as Cl minus is not showing any basic properties, that is why this kind of a reverse arrow is not appearing with this ionization of HCl. That is why we say HCl is a strong acid, because only one way the dissociation occurs. Right now? So if you had examined some other stuff as well, right? So if you had to think of some other thing which is not a strong acid, CH2COH. So they also are coming up with these double arrow situations. So see, with these three you clearly see the conjugate base of CH2COH is with some measurable basic property. This is a weak acid. So this is your conjugate base. If you are a weak acid, then your conjugate base is with some measurable acid basic property. So this CH2COH minus accept an H plus, and by the reverse reaction will produce this thing. So that means this guy is with some measurable basic property or basic strength is there with this one. but not with this one. This one won't accept H plus to produce the HCl again. So we can say no measurable basic property as you are coming from a strong acid. As you are coming from strong acid. That is what it says. All the conjugate bases from strong acids are not with any basic properties, no measurable basic property. But when you are dealing with weak acids, yes, they are with some basic property. That is why you see the reverse arrow, double arrow situation with the weak acids. Right? Not complete dissociation is mentioned like this, no? With double arrows. Okay. Now what we are discussing is this thing, right? If an acid is strong, if you are dealing with strong acid, its conjugate base, this thing is not with the measurable strength. Let's come up with some more examples with these some of the more strong acids. See, the HNO3 is also known as a strong acid. So it's a singular situation. So H plus AQ, it will dissociate to H plus AQ and NO3 minus. So NO3 minus, which is the conjugate base of a strong acid, is strong acid. That is why singular resolution is there. This is a conjugate base. You clearly see that guy won't accept H plus to produce the HNO3 again. So no reverse arrow is there. So this guy is not going to accept the H plus. Right? So no acceptance of H plus, that means no basic property. No measurable basic property. So like that, for all the strong acids, the same thing valid. So it comes H2SO4. This is also a strong acid. What is the ionized form there? So if it is to release some H plus, it's going to be H plus. After releasing H plus, we will come up with the HSO4 minus, HSO minus as its conjugate base. HSO minus is the conjugate base of H2SO4, right? Not the SO42 minus, right? Not the SO42 minus. SO42 minus is not the conjugate base of HSO, not the conjugate base of H2SO4. To come up with the conjugate species, you can have only a difference of just one H plus, right? So HSO minus is the conjugate base of H2SO4. So that is the conjugate base. So we know it is not with measurable basic property. That is why the single arrow thing appears. No measurable no measurable basic strength. Thing is clear? So we can think of more acids like HClO4, another strong acid. Right? Few are given, right? Okay. HCl like HCl, HBr, HI, those are also strong acids. For their anions, Br minus I minus anions. When it comes to HClO4, the ClO4 minus ion. Those are the conjugate stuff of the strong acids. Those are not with any measurable basic property. So basic thing is not there. Right? Is what it says. See? You can go to the stuff, right? Example, Cl minus ion, which is the conjugate base of the strong acid HCl, is an extremely weak base. Extremely weak, I mean, no measurable basic property. Extremely weak means, not considered. The basic nature is not considered there. Right? And some equation is also there, which will be proved, right, at the next class, not today. Some expression is also there as Ka into Kb is equal to constant. This is known as Kw. This expression will be proved at the next class. Today it is going to be a shorter session, right? So there will be equation like this. The next class we will prove this thing. So K values are measure of products, right? K values are measure of products. So when it comes to hydrolysis reactions of acids, At the product side, H pluses are there. H pluses are there. Right? So Ka, the equilibrium constant of acid, the Ka is going to be a measure of H pluses released by the acid. Right? It's a measure of acidity. The Ka is a measure of acidity. Like that, Kb is a measure of basic nature. So when you are thinking of high list of a base, at the product side, the OH minus ions will produce. So more the products, more the K value will be. So B is the dissociation constant of or the equilibrium constant of the base. So more the OH minus is produced, more will be the K value, greater will be the K value. So it is all about the basic nature of the base, right? So Ka is a measure of acidity of your acid. Kb is a measure of basic nature of your base, right? Okay. So for a conjugate pair, the Ka-Kb multiplication is equal to constant. For a conjugate pair, Ka-Kb multiplication is equal to constant. We'll derive this thing at the next class. For the time being, just consider this as it is, right? Okay. So with this one as well, we can prove this stuff, right? If you are with a strong acid, that means this Ka is very high. K is very high. K is very high. That means your Kb is going to be very low. Kb is going to be very low, right? If you consider strong acid, that means your K will be very high, going towards infinity. So the Kb is going towards 0, as this one is should be a constant, right? With use of this equation as well, we can discuss about the same statement. For a conjugate pair, this is appearing, right? This is a measure of acidity of the conjugate acid. This is a measure of basicity of the conjugate base. But that multiplication is going to be a constant. We'll prove that thing in the next class. So when the acidity is high, when it is a strong acid, when the acidity is high, the basic nature is very low. When this goes to infinity, this goes to 0. Right? Okay, this is clear now? Right, that thing is given there, right? This can be mathematically driven by the equation Ka into Kb is equal to constant, right? So equilibrium constant for the hydrolysis of conjugate acid, Ka, Kb is the equilibrium constant of hydrolysis of conjugate base, right? Here Ka high means the acid strength is high, Kb high means base strength is high, and you can come up with the idea there, right now? Okay. Next one, right? That is the first thing, right? About the conjugate pairs, right? If you are dealing with a conjugate acid, its conjugate base is not with a measurable basic property. So we can say 0 even, right? Okay. Right. Next one, let's come up with the second important fact, right? If you need to write anything, right, just write this stuff, right? I'm not going to give you any more time, right? Or should I right? Okay. Right. Let's come up with the second point. Point number 2, right? Let's first read the stuff. H3O plus is the strongest acid that can exist in an aqueous solution. That is what it says. Just highlight this stuff, Lama. Just highlight this that phrase or the statement, right? H3O plus is the strongest acid, right? H3O plus is the strongest acid that can exist in the aqueous solution. In an aqueous solution. Right? හරි මේක මෙහෙම case එකක් තියෙනවා. The idea is this. හරි මම පොඩි කතාවක් කියන්න. I'll tell you a story. right දැන් අලම දින්නේ මේ නේද ඔය දින්නේ කීපති වල right මේ අර මේක තවත් තියෙන මේක අපේ සීමාව හරි අර කියන්නේ අර අර බින්තරකන් එහා පැත්තට ඇවිල්ලා සද්ද දාන්න එපා කියලා හරි ඒ වගේ තමයි හරිද ඒක අපේ සීමාව අපේ සීමාවට ඇවිල්ලා අපිට සද්ද දාන්න එපා අන්න ඒ වගේ සීන් එකක් තමයි දින්නේ හරි මේක අපේ වැයික්කිය අපේ සීමාවට ඇවිල්ලා අපිට සද්ද දාන්න ඉන්න එපා චණ්ඩියෝ ඉන්නවනේ අන්න ඒ වගේ චණ්ඩියෙක් තමයි H2O+ කියන්නේ in an aqueous solution the chandiya is H2O+. Right? H2+ is the strongest acid which can exist in an aqueous medium. Aqueous medium කියන පුළුවන් strongest acid H2+. එයාට උඩින් යන්න කාටවත් එන්න බෑ. එයාට උඩින් කාටවත් යන්න බෑ. aqueous solution එකේ වැඩ ලොක්ක H2O+. හරි? aqueous medium එකේ ඉන්න ලොක්ක H2+. strongest acid එක. හර එලියෙන් එන්න බෑ යටට වැඩියෙන් strong කට්ටියට. එලියෙන් එන එලියෙන් acids ආවට කමන්නේ. We can add acids. But that acid which you are adding, right? The acid you are adding from the outside, if that is stronger than H2+, then it can't appear at the aqueous solution. It can't be there. It can't last in the aqueous solution. H2O+ තමයි මේකේ වැඩකාරයා. හරි? H2O+ තමයි මේකේ ඡන්දියා aqueous solution එකේ. H2O+ වඩා ඡන්දි කට්ටිය ඉන්න පුළුවන්. හැබැයි H2O+ කි සීමාව ඉන්න බෑ. හරි අපි කොච්චර ඡන්දියක් වුණාද අර බෙන්තරකන් එහාට ගියාට පස්සේ අපි ඡන්දි ගාම කරන්න නැති වෙනෝනේ කේස් එක හරි ඒ වගේ තමයි හරි නැත්නම් H2+ කතාව ගත්තොත් නේද H2+ තමයි ඡන්දිය එයාට වඩා ලෝකෙ හොල්ලපු ඡන්දියෝ ඉන්න පුළුවන් ලෝකෙටම ඡන්දියෝ ඉන්න පුළුවන් හැබැයි H2+ කි සීමාවට පස්සේ ඔය හැම ඡන්දියම නොන්ඩිය වෙනවා එහෙම තමයි මොන කට්ටිය නේ මොන ඡන්දියද එහෙම තමයි හරි ලීසි නේ හරි ඒතර වෙන එකෙක්ගේ සීමාවට ගිහිල්ලා ඇටැක් කරන ලේසි වැඩක් නෙවෙයි කොච්චර ඡන්දි වුණා හරි ඔක තමයි කතාව මෙතන so H2+ is the strongest acid that can appear in an aqueous solution right if you have to add some acid which is with greater acidity than the H2+, what happens it can't last in the aqueous solution even for a moment. But if you are adding some weak acid than the H2+, no worries, no worries. H2O+ doing nothing to such weak guys. But what you are adding from the outside is stronger, looks like stronger than H2+, then definitely H2+ will attack that thing and completely destroy that species. Completely consume that species. If what you are adding is a stronger one, strong acid than H2+, completely reacts, completely destroy the species. But if you are adding from the top, if you are adding from the outside, is actually weak acid than H2+, no worries, H2+ won't harm those weak guys. Don't do anything for weak guys. එහෙමනලමනේ අපේ වෙයි කියලා මේ මිනේ අර ඔය නිකන් දුබල පොඩි සොක්ක වෙනවනම් බය වෙන්න දෙයක් නැහැ. ඉතින් H2+ මුකුත් ඒකට කරන්න යන්නේ නැහැ. අනේ ඔහිලා ඉන්නේ ඉතින් ප්‍රශ්නේ Tamanට බාධාවක් නොවන තාක්කල් Tamanගේ නේද? Tamanගේ බලයට බාධාවක් නොවන තාක්කල් ඕන එකෙක්ව බාර ගන්නවා. සාමාන්‍ය මනුස්ස ස්වභාවය එන්නේ නේද? Tamanට ඇටැක් කරන්න Tamanට වඩා ලොක්ෙක් ආවොත් එහෙම දෙන්නේ නැහැ. Tamanට වඩා ලොක්ෙක්ට විතර එස්ටැබ්ලිෂ් වෙන්න දෙන්නේ නැහැ. Tamanට වඩා පොඩි උන් එනවනම් ආනේ කමන්නේ ඔන්න ඔය ඉන්නේ කියලා දෙනවා. තරහ ලොක්කෙ මෙතනට එන්න දෙනවනම් ඌව කෙලින්ම කපලා දානවා. හරිද? එහෙම තමයි මේ බලේ තියාගන්න H2+ එකයි. බීම ගන්න. හරිද? බලමු වැඩි ලස්සන කරන හැටි. මේ බලන්න. වැඩි යන්නේ. right? ඉතින් ලියලා මේ මොකද්ද? point එක. That is stronger than H2 plus. That is stronger than H2 plus. Can't be there in the aqueous solution because H2 plus will totally destroy that thing. අපිට වඩා දෙකිනු ඕක කෙලින්ම ආපු වෙලාවෙම කපලා දානවා. ඉවර කළා දානවා. Right? Completely. That be irreversibly. Completely. Reacts with water. To produce H3O plus and the conjugate base and its conjugate base. Right? දැන් අර මොන කතාව? හරි? ඔයාගේ ඇසිඩ් එක H2 plus ඕම ඉන්නවා H2 plus level එක. ඔයා දාන ඇසිඩ් එක මෙයාට වඩා උඩින් නම් ඉන්නේ. හරි මෙයාට උඩින් නම් ඉන්නේ. එහෙම ඉන්න දෙන්නේ නැහැ. කෙලින්ම වස්සන H2 plus level එකටම. එතනට උඩ යන්න බෑ. ඇසිඩ් එක මෙයාට උඩින් නම් ඉන්නේ ස්ට්‍රෝං නම් එහෙම ඉන්න බෑ. කෙලින්ම H2 plus level එකට වස්සනවා. විරක් කළා දාන ඇසිඩ් එක කෙලින්ම H2 plus level එකට වස්සනවා. ඇසිඩ් එක මෙයාට වීක් නම් කවුරුත් නැහැ. යටින් ඇසිඩ් එක ඉන්නේ ප්‍රශ්නයක් නෑ. ඔහොම ඉන්නවා ඉන්න no worries you can exist. ඇසිඩ් එක මට ස්ට්‍රෝං නම් ඉන්න දෙන්නේ නෑ. ගෙලින්ම H2+ මට්ටමන බස්සනවා. අද දාන් આવොත් නේ ගෙලින්ම බස්සනවා ආයි. ඒ මට්ටම. හරි. දැන් උදාහරණයකට මේ බලන්න. දැන් HCl වගේ කෙනෙක් ගත්තොත් that is why we write the HCl hydrolysis reaction with a straight arrow. With a straight arrow. With straight arrow. Straight arrow. Straight arrow means complete reacts. The limited reagent completely reacts, right, to produce the H3O plus and the conjugate base. Further, the straight arrow means this is a strong acid. Now, this is a strong acid කියලා කියන්නේ එහෙමනේ. දැන් අර දැන් මෙතනට කලින් දැන් මම මේ දේ කතා කරන්න කලින් even at the small ages you had categorized the HCl as strong acid, and CH3COH as a weak acid. But there is a problem නේ ළමයි. Strong acid compared to which? A strong acid එකක් කිව්වට පස්සේ අනිත් එක weak acid එකක් කියලා කිව්වට පස්සේ compared to which? කාට සාපේක්ෂවද? Relative to which one? The HCl is strong. Relative to which one? The CH3COH is weak. We had a problem there. ප්‍රශ්නයක් තිබ්බා අපිට ඒක හිතුණු නැතුණාට. අපිට හිතන්න ගියේ නෑ අපි. පොඩි කාලේ. ස්ට්‍රෝං කිව්වට පස්සේ නේද? කාට වඩා ස්ට්‍රෝංද? නැත්නම් මොකද්ද සීමාව? කොතනින් වැඩි නම් ස්ට්‍රෝං කියලා කියන්නේ? ඇසිඩ් කොතරට වඩා වැඩි නම් අපි ස්ට්‍රෝං කියලා කන්සිඩර් කරන්නේ? ඇසිඩ් කොතරට අඩු නම් අපි වීක් කියලා කන්සිඩර් කරන්නේ? What is the criteria to decide the strong weak nature? Yes, this is the criteria. If your acid is stronger than H2O plus, it is referred to as a strong acid. If your acid is weaker than H2O plus, it is referred to as a weak acid. That is the criteria of categorizing as strong and weak for acids. Right? H2O plus වඩා එයා ස්ට්‍රෝං නම් එයාට අපි ස්ට්‍රෝං ඇසිඩ් එකක් කියලා කියනවා. H2 plus වඩා weak ඇසිඩ් එකක් නම් එයා weak ඇසිඩ් එකක් කියලා කියනවා. That is relative to the H2O plus. The categorization is done. So, according to this theory, it says the strongest acid that could appear in an aqueous solution is the H2O plus. If acid is stronger than that, if your acid is stronger than the H2O plus, what will happen? It will totally consume. It will totally consume, I mean, totally consumes. So the limited, this stratum is the limited reagent totally consumes. Right? The limited reagent is definitely HCl. So in aqueous mediums, more water are there, right? More water are there. This is the limited reagent, right? So this will totally consumes. So this thing will totally consume. This will thing will totally consume to produce the H2 plus and the conjugate base. That is what happens if your acid is stronger than H2 plus. Right? Clear? So it will produce the H2 plus and the conjugate base. Conjugate base. Right? This is just, what will happen if your acid is weaker than H2 plus. Right? Acids weaker than H2 plus, what will happen? So it is then no worries, Lamai. If you are weaker than H2 plus, no worries. You can be there. You can exist in the aqueous solutions. You are weaker guy, weak කට්ටියට මුකුත් බාධා කරන්නේ නැහැ. Weak උන්ට ඔහු ඉන්න දෙනවා. Right? As is weaker than H2 plus. Right? React with water to much smaller extent reversibly complete react කරන්න ළමයි producing H2O plus and its conjugate base. As products, always the H2O plus and the conjugate base will be produced if you are an acid. Right? Let's consider such kind of a weak acid. HF is kind of a weak acid with a hydrolysis reaction. As it's a weak acid, that is not going to react completely. Very few molecules will react. Like 4 molecules out of 100, like 5 molecules out of 100, very few will react. But most of the guys, out of 195%, will appear without reacting, will appear in the aqueous medium without reacting. So anyway, the very few amount reacted will produce the H2O plus and its conjugate. The HF's conjugate is F minus, conjugate base is F minus. Right? That is clear now? So, according to whether you are stronger or weaker than the H2O plus, right? The irreversible nature of the hydrolysis reaction, right, will be decided. The irreversible nature of the hydrolysis reaction will be decided by concerning whether you are stronger or weaker than the H2O plus. But anyway, if you are an acid, definitely it will produce the conjugate base and the H2O plus as products. But whether it is irreversible or reversible, that will be decided by the strong or weak nature compared to H2O plus. Right? That is the summary there. Right? සාමාන්‍ය මේක ගත්තොත් ළමයි, if you are to come up with 100 molecules, 95 molecules will appear as HF. Only very few 5 molecules will dissociate as the F minus and the H2 plus. Almost all the molecules will appear as HF, so they can last in the aqueous solutions if you are weaker than H2 plus. But if you are stronger than H2 plus, no molecule is able to be at the aqueous solution. All will be consumed, all will be attacked, and all will be consumed. 100% consumption. right? Okay, things are clear. Okay, so just highlight the two thirds of lemma here. Just highlight this acid stronger than H2 plus, and this one acid weaker than H2 plus. Just highlight the two stuff. Anyway, they produce the H2 plus and the conjugate base as you are an acid. The complete reaction or the partial reaction, double reaction, will be decided by strong or weak nature compared to H2 plus. Right? දැන් මේක හරිය ලස්සනට අහන්න පුළුවන් first statement second statement question එක. This thing can be examined as a first statement second statement question. See, the first statement could be like this. First statement could be like this. The hydrolysis of HCl, the hydrolysis of HCl can be represented as this first statement. Hydrolysis of HCl can be represented as HCl aqueous plus H2O goes to H3O plus and the Cl minus. That is the first statement. Hydrolysis of HCl can be considered as this කියලා මේ statement එක දී. That is true. First statement is true. The second statement. HCl is a strong acid than H2O plus. HCl is a strong acid than H2O plus. HCl is a strong acid than H2O plus. That is also true. That is also true. Your answer is answer number one. Answer number one. HCl is a strong acid than H2O plus. That is true. And answer is going to be answer number one. That is why you are right in the reaction with a straight arrow. That is why you are right in the reaction with a straight arrow as irreversible reaction, as HCl is a strong acid than the H2O plus. Right? So such kind of question can be appear in your MCQ paper, right, from this section. Right? Things are clear. So if you need anything, just write the stuff, right? All right. Next one. Let's come up with the bases as well. Like in acids, there's a king for the bases as well. Right? Acids වලට රජෙක් ඉන්නවා වගේ නැත්තම් නේද? acids වලට ඉන්නවා වගේ පොරක් ඉන්නවා වගේ H2 plus කියලා. බේස් වලට පොරක් ඉන්නවා. කවුද පොර? The OH minus. The OH minus. So OH minus is the strongest base which can appear in an aqueous solution, in an aqueous medium. Right? You think of the basic stuff. Bases ගැන හිතුවොත් ටිකක් තියෙනවා. හරිද? OH minus is the strongest base which can appear in an aqueous solution. So if you have to add some base which is more stronger than the OH minus, definitely that guy will completely react. That's the next point, right? So point number 3, OH minus is the strongest base that can exist in an aqueous solution. Right? So bases stronger than OH minus completely reacts with water to produce what? Produce the OH minus and conjugate acid. If you are a base, the products are going to be OH minus and conjugate acid. Products are going to be OH minus and conjugate acid. Like in the earlier case, if you are considering a base weaker than OH minus, then they can appear in an aqueous solution. react with water to much small extent. It will produce anyway. They will also produce the OH minus and its conjugate acid. හරි බේස් එක ගන්න ළමයි හදන්නේ OH minus and conjugate acid other products. If you are a acid, it will produce the H2 plus and the acid and H2 plus, right? And the conjugate base, right? Okay, let's copy some example for this thing. The same logic. Base එකක් දාන්න එහෙම තමයි, right? So this is the level. This is the level. Coming up with the H2, so OH minus. If you are coming up with some stuff which are with greater basicity, like O2 minus, those guys can't appear there. Those will be, the strength will be decreased to the OH minus level. If you are coming up with weaker bases like ammonia or some guys, right? So then they can appear. They can appear in the media. Aqueous media. Not the O2 minus. Right? Okay? See the things appearing at the page number 4 of a tube. Right? The OH minus ion is the strongest base that can exist in an aqueous solution. Base stronger than OH minus can't appear. Completely reacts with water to produce OH minus and the conjugate acid. So if you need some examples, see. So O2 minus is a strong base than the OH minus. So completely reacts with water to produce what? OH minus and it's a base, no? So produce OH minus and what? The conjugate acid. This H plus will be released. One of the H plus will be released here. Right? That is how the OH minus is produced. And this becomes the conjugate base. Sorry, conjugate acid. OH minus and conjugate acid. The conjugate acid of O2 minus is the OH minus. Conjugate acid of O2 minus is the OH minus. Conjugate acid of O2 minus is the OH minus. Right? So let's complete a few other. Then H2 minus. When reacting with H2O, it will produce the OH minus and the conjugate acid. Conjugate acid. So conjugate acid of this thing is NH3. Just add NH plus. Just add NH plus to the species to come up with the conjugate acid. So NH2 minus with H plus, this is NH3. So H minus is another strong base than the OH minus. So that water will completely react that thing to produce the OH minus and the conjugate acid. What is the conjugate acid of this? Conjugate acid means you have to just add NH plus to this. So if you are a base, you will come up with the conjugate acid, right? H plus and H minus will give you the H2. These are some reactions coming up with the inorganic chemistry, right? If sodium oxide to put into the water, it will produce sodium hydroxide. Produce sodium hydroxide. If sodium amide NaNH2 is to put into the water, it will produce the NaOH and NH3. Then lamai, if you are adding some NaCl to water, that won't hydrolyze, no? That won't react with water. No? If you add some NaCl to water, it won't react with water. Why is that? Because Cl minus ion there is very weak. It's a conjugate base coming from the weak acid, coming from a strong acid. The Cl minus, we have learned that thing. So Cl minus is so weak, weaker than the OH minus, so that it can appear in the solution. It can appear in the solution like this. That is why if you add NaCl, to water, nothing happens. The Cl minus will appear as Cl minus Aq. If you add some NaCl solid to water, it will appear as Na plus Aq and Cl minus Aq. But not the O2 minus. If you add Na2O, the Na plus ions and the O2 minus ions to the aqueous solution, the O2 minus aqueous won't be formed. What will happen is the O2 minus will completely react to form the OH minus. So you won't see, if you add some Na2O to water, you won't observe Na plus and the O2, Na plus Aq and the O2 minus Aq, like in the NaCl case, as Na plus and the Cl minus. You won't see the formation of Na plus Aq and the O2 minus Aq. That O2 minus will completely react, totally consumes to produce the OH minus and its conjugate base. Conjugate acid, sorry. That is why, because O2 minus is kind of a stronger base than the OH minus. Even this one, if you add the NaNH2 to water, you won't see the production of Na plus Aq and the NH2 minus Aq. No, NH2 minus Aq can't last in the aqueous solutions because NH2 minus is a stronger base than the OH minus. So that NH2 minus will completely react and consumes to produce the OH minus and the conjugate acid. That is the same, that is what happens with the H minus as well. Right now? Okay, that is the idea here. Right? Shape neither. If your base is weaker than the OH minus, no worries. If your base is weaker than the OH minus, no worries. Right? No worries. Right? So then the NH3 can never get weak base. No worries. Weak base. That means a base which is weaker than OH minus, right? That is why it can last in an aqueous solution. Even though you are producing the OH minus and the conjugate base, conjugate acid, OH minus and conjugate acid is formed as products, whether you are dealing with a stronger or weaker one. But it's coming up as a double reaction as it's a weak species, right? Conjugate acid is NH2 plus, right? Acid of system. Anyway, double error. Because this can last. That is why this is not completely reactant, right? Because this is a weak acid than H2 plus. Sorry, weak acid than OH minus. Right now? That is the idea. That is the idea, right? Things are given. Let's go to the note there. So ultimately it says, for this reason, O2 minus, NH2 minus and H minus ions do not exist in aqueous solutions. Do not exist in aqueous solutions, right? So the reasons for the inorganic reactions are now understood. Right now? Okay. As the final exercise, just complete those reactions. Just complete those acid-base reactions. Just hydrolysis reactions. Otherwise, anthim wedi thamai. Then what acid-base reactions, hydrolysis reactions clearly. So you should be able to clearly write these reactions, right? This lesson is all about writing reactions. If you are unable to come up with the correct reaction, correct acid-base reaction, basically the hydrolysis reactions, hydrolysis means reacting with water, right? You are unable to continue the lesson, right? So just the fundamentals today. So just try to come up with the reactions there. Simply what is to be done is, if you are dealing with acid, the hydrolysis will produce the H3O plus and the conjugate base. If you are dealing with acid, it will produce the H3O plus and the conjugate base. Acid nang H2O plus adan noni. Yate conjugate base. If you are dealing with a base, hydrolysis of a base, then you have to produce the OH minus and the conjugate acid. Or base again hydrolysis of a base now, you have to produce the base na OH minus produce karnone with the conjugate acid. That is how we are supposed to come up with the products, right? And if you are stronger than H2O plus, that is straight arrow thing. If you are weaker than H2O plus, that is a double arrow thing. If you are stronger than OH minus as a base, it's a straight arrow thing. If you are weaker than the OH minus as a base, it's a double arrow thing. That's how we are supposed to right? Come up with the arrows, whether it's a single arrow or double arrow. The products are considered as I have mentioned earlier. Just come up with the 5 exercises. Yeah, that's the last thing to do today. I write it in the board as well, right? For the ones who haven't got the tute yet. All right. This is the question, no? Test or knowledge question. Question is complete the following. Acid-base reactions. Right? These are the reactions we are supposed to write. HBr plus H2O. Number 2, CH3COH plus H2O. Now, when writing reactions, it is needed to come up with the physical states, right? This is physical chemistry. If you're not writing in the physical states, you won't get marks. NH4 plus and H2O. RNH2 plus H2O. Fifth one. NH2 minus plus H2O. Let's complete. Just try to come up with the first write the products. After that, just consider whether it's a straight arrow or double arrow. හරි අපි ලියමුද? හරි මුලින්ම ළමයි මේ products එක ලියලා ඉන්නකෝ. පස්සේ consider කරනවා straight arrow double arrow කියලා. Right? First write the products. Let's write the products here. First of all. So HBr is kind of acid, huh? Anyway, it's acid. Strong the weak the පස්සේ බලමු. So acid with the water, acid with the water. So acid with water should produce the H2O plus. H2O plus and the it's acid too. H2O plus and the conjugate base. Conjugate base. Conjugate base means releasing an H plus and writing the stuff. Conjugate base. Conjugate base of this thing. Releasing an H plus and writing the stuff. First come up with the products. ළමයි අපි මුලින් products ටික ලියමු. මුලින් products ටික ලියමු. ඊට පස්සේ straight arrow double arrow කියලා පස්සේ ලියමු. This thing. arrow එක පස්සේ දාමු. arrow එක පස්සේ දාමු. First write in products. This kind of acid. This guy is a kind of acid. Acid now. You have to come up with H2O plus as a product. Acid ne? H2O plus is kind of and its conjugate base. H2O plus and the conjugate base. The conjugate base of this thing is what? Releasing H plus and coming up with species. CHCO minus. CHCO minus. Right now? Okay. Next thing. This one. NHO plus with water. So NHO plus, we know ammonium salts are acidic. Ammonium salts are acidic. This is ammonium salt. Ammonium salts are acidic. So it's an acid. So if it is an acid, the product should be the H2O plus and its conjugate base of this thing. Conjugate base of this thing means you are supposed to release an H plus and write. Conjugate base thing. So you have to come up with the base. Base means the species with less H pluses. So that is the NH3. You have to release some H plus and write. Release an H plus from here. It's going to be NH3. So physical state should be written. Make was leave. This one. It's a base. Amine. It's an amine. Organic compound. Amine. Amines are bases. This lone pair on nitrogen can be donated. Amines are bases. So that amines will react with water. How is this? To produce what? As it's a base, should produce the OH minus. Base nang OH minus unknown. With its conjugate acid. The conjugate acid of this thing. Conjugate acid means the one with more H pluses. So just add an H plus to this one and write RNH2, add an H plus will give you RNH3 plus. RNH3 plus. තේරුණේ දැන් ඔයගොල්ලට ඔය conjugate pair එක හරිය ලියන්න ගෙන්නුවේ කියලා. හරි? reactions ලියන්න අනිවාර්යයෙන්ම conjugate pair එකේ knowledge එක ඕනේ. එක්කෙනෙක් දුන්නට පස්සේ ආයේ conjugate species කොහොමද ලියන්නේ කියන එක වෙන idea එකක් ඕනේ. How to write the conjugate acid if a species is given and how to write a conjugate base if the species is given, should be able to do so. පස්සේ මේ arrow එක ලියන්න. This one NH2 minus. NH2 minus is a base, no? NH2 minus is a base. NH2 minus is a stronger base than NH minus even, right? So basic stuff. So if you are with a minus stuff, if you are with minus things, definitely those are keen to accept H pluses. The minus particles are keen to accept plus charges, plus guys. So normally in hydrolysis, right, if you are a minus particle, those behaves as bases. The OH minus is a base, NH2 minus is a base, H minus is a base, O2 minus is a base, CO32 minus is a base. Right? Minus guys are keen to accept H pluses, opposite charges attract. So accepting H pluses means bases. So NH2 minus is kind of base. So what is reaction? NH2 minus is H2O. As it's a base, you should produce the OH minus and base nang OH minus adannu and its conjugate acid. The NH2 minus conjugate acid is, so you have to add some H plus and write the stuff, right? It's going to be NH3. Writing the conjugate acid means add an H plus and write. Okay, now the products are done, right? Now what I ask is to come up with the reaction arrows. Use your knowledge about what you know, whether it's a strong or base, strong or weak. What strong the weak the kilo dana knowledge use kalega arrow dan. It's odd win never. Look what are H2O plus the vada acidic the OH minus the acidic the basic the gila him hitan never. Hurry, make that the him look what is never. We are done nothing in a cow to the report of OH minus H2O plus consider compare. If you are dealing with known stuff, just use that knowledge to come up with a straight arrow or double arrow. HBr is considered as a strong acid. HBr is considered as a strong acid. HCl, HBr, HI, the hydrogen halides other than HF, the hydrogen halides other than HF are considered as strong acids. So it's a strong acid. So it's a strong acid, that means straight arrow. Strong acid. CH2COH, you know it's a weak acid. CH2COH, from small ages, you know. All the organic acids are weak. All our concerning organic acids are weak. We have two organic acids which are strong acids. The two guys are CF3COH and CCl3COH. Other than those two, all the other organic acids are weak acids. Other than the CF3COH and the CCl3COH, other than these two, all the other organic acids are weak acids. So this is a weak acid. So weak acid means double arrow. Right? Aramega. Ammonium salts. Ammonium salts. Ammonium salts it was strong acid enemy. Ammonium salts coming from the ammonia and the stuff, right? It is not that much of a strong acid. Right? It's just acid, right? So knowledge strong acid enemy. Strong acid kill strong acid in there. Strong acid kill strong acid kill HCl, HBr, HI, HNO3, H2SO4, HClO4. ඔය දන්න ටික විතරයි. ඔය දන්න ටික ගන්න. දුරු කට්ටිය weak කියලා ගන්න සික්සල්. මෙයා all the organic bases are weak bases. All the organic bases are weak bases. Organic කට්ටිය ළම acids ඔක්කොම weak acids, base ඔක්කොම weak bases මේටි කරන්නේ. organic ලා ඔක්කොම weak acids, weak bases මේ දෙන්න හරියට. අපි syllabus එකේ නා. එහෙනම් weak base නා double arrow. NH2 minus. Now NH2 minus කියන strong base එකක් අපි කලින් කතා කරා. හරි? The ability of NH2 minus of releasing the lone pair is greater than the OH minus. NH2 minus ability to release the lone pair is greater than the OH minus because the lone pair is appearing on the nitrate, less to nitrate. So releasement of this lone pair is greater than the releasement of the lone pair of the OH minus. Right? So basic nature is greater. For the NH2 minus than the OH minus. So it's a strong base. It's a strong base. It is easy to release the lone pair on nitrogen than the lone pair on oxygen because nitrogen is less restrictive than the oxygen. Restrictive means easy to release the lone pair. Right? So NH2 minus is strong base, so that it should appear as a straight arrow reaction. Totally should consume to produce the OH minus and the conjugate acid. Right now? So that's it. The reason for this is eternity. Of nitrogen is smaller than oxygen. Right now? හරි. එනවා තමයි කතාව. ඉතින් ඔය විදිහට අපි hydrolysis reactions ගියාම බලුවා. ඉතින් මේ session එක ලා හොඳට බලන්න. හොඳට මේක මේ පාඩම් කරන් ඉන්න next week එකේදී. හරිද? මේ අපි මෙතනින් තමයි වැඩි පටන් ගන්න. You should be able to easily write the hydrolysis reactions, right? Without writing the hydrolysis reactions, you can't continue the lesson, right? So just study this stuff, right? And come to the next class, right? So from here, I'm going to stop the lesson for today, right? From next day onwards, we are going for the major stuff of the acid-base chemistry. These are just fundamentals, right? Okay, hari now ena අපි අදට මෙතන නවතිමු. Next day එකක් තමයි, right? Goodbye then. cinestic.